In this video, I'm going to go through the final exam review packet for Chapter 4, and that means questions 19 and 20 on your review packet. Now, in my class, I handed out some cards that kind of talked about domain and range, and you might recognize these, but if you don't, I'll kind of talk about them briefly. To identify domain of a graph, I kind of imagine curtains, and those curtains, what they want to do is open up to see where is the leftmost point on your graph and where is the rightmost point. So as I open it up, how wide do we need to open to look for our x values? If you see an arrow, that would mean that your left goes on for negative infinity, and if you see an arrow to the right, that means the right side of your graph goes to positive infinity. So as I'm looking at this picture here, if I start in the middle, and I start opening up these curtains and keep going, keep going, keep going, keep going, those arrows indicate to me that it will keep going to the left and keep going to the right, meaning the graph will continue to get wider and wider. So this is how you're going to write your inequality for your domain. It's going to be negative infinity less than x less than positive infinity. And all you need to do is add some curly brackets to make it a set. And that's it. So this graph is going to get, as it comes from the vertex, wider, 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 wider. And as it goes wider, it means it continues to go to the left and it continues to go to the right. Now the range goes this way. Here we go. Highest point to lowest point. So kind of like we were opening those curtains left and right, now we're going to do kind of like what I refer to as like a garage door. How high can it go? How low can it go? Well, I can definitely see the highest point on my parabola, and I see that the y value, because range is the y, so on this y-axis, that value there, the highest point is 2. And then I see that down here, as I'm opening my curtains or my garage door, because those go up and down, the lowest I see here is an arrow, which means that that's going to keep going lower and lower and lower, which means negative infinity. So from lowest to highest, I have negative infinity because that's going to continue to go low. Now notice how I have a y value in the middle, and because range is y values, and the highest point is equal to a value of 2 on my graph. So equal to here, because this is for sure a point on the graph, but you can never really equal infinity because infinity implies that it keeps going, and if that keeps going, then it never really equals a number. It's kind of like it goes on, and so that's why we're not going to use an equal to here. Now for the function, whether you circle yes or no, what you need to do is look at what is called the vertical line test. Now if you can draw a vertical line through your picture and it crosses one time only, then that means it passes the vertical line test. Another way to indicate if you have a function is to just look for repeated x values. Specifically the x. Don't worry about what happens with the y, because that doesn't have anything to do with whether it is a function or not. So if an x value repeats, it would not be a functioning relationship. And so if you look for a vertical line, if it passes through more than once, then that means an x value repeats, so therefore not a function. But if it goes through once, that's okay, so then it is a function. All right, now, when you have a set of points, you're going to list out a set of points for your domain and range. Unlike this continuous function where we had to graph an interval, this is not a continuous function. It's a very distinct set of points, so they call that discrete. So with a discrete set of points, I think it's a little easier, just for me visually, to look at my points and then label them as their x and y, and then it's easier for me to order my domain and range. So my first point is -6, 5. My next point is -4, 4. My next point is -3, 3. And then -3, 2. And then -1, 4. Now my domain is my x values. So it's going to be all of these values written out from smallest to greatest. Do not list repeats. So the smallest x value I see there is -6, then -4, then -3, which repeats. I'm going to put a little r up there to tell myself it repeats, and then -1. So because I see that -3 repeats, that's why I put that R there, I know that this is not a function, because if an x value repeats, not a function. Now, the y values that you have over here in this column are for your range, and so we're going to order those from least to greatest again. Don't list repeats. The smallest value I see is a 2, then I see a 3, then a 4. Don't list the repeat. It doesn't matter that you're 4 repeats for your range, and then 5. But in your list, don't list out the repeats. And that is domain and range. Now I have a couple more questions for chapter 4 that don't deal with domain and range. They deal with specifically function notation. Now I want you to see that the functions that you are given have a name. Now this function is called the f function, and it is -3 fourths x plus 2. And then you have a g function over here where you have x squared minus 5x plus 3. Now some students have asked me, well, Ms. D, why the name? Why don't they just call this y equals? And why don't they just call this y equals? And here's my answer to them. If you named both of these y, and I said substitute y equals 2, how would you know which function to use? And so instead of saying like y subscript 1 and y subscript 2, like function 1 and function 2, they just give them names. So I kind of just, in my mind, I think of this as f of x, but I call it in my mind, hey, that's Frank's function. And then g of x meaning like, hey, Jerry, that's Jerry's function. So it's just kind of a name, but it means y equals, and that's your function. So think y equals mx plus b is what you have here. And this one you just have a parabola, so you have a square term, a linear term, and a constant. Now for all of these, we're going to do some substitution. And if you notice, you had f of x and you had g of x. I'm going to highlight these just to kind of help us out. Where I see f of x, I'm going to use that green function that I highlighted because that's the name that that function goes with. And where I see the g of x, I know I'm going to end up using the yellow highlighted function here. And now that you see that x is in parentheses, notice what the x has turned into here. So that means our x has turned into 8, which means sub in 8 for x. So my function is -3/4 x, which now I'm going to replace with the number 8, plus 2. And now we'll just use my calculator to solve. So -3/4 times 8, and then I'm going to add 2. And I get an answer of -4. For the next one, f of -4. So in place of my x, notice how that x turned into -4. That means I'm going to do a substitution where x equals -4. So -3/4 times -4, and then plus 2. Well, these are going to cancel out. And my negative times negative is going to mean I have +3 plus 2, which is going to give me an answer of 5. For the next one, for the g function, what we're going to do is substitute in for the yellow highlighted function for x, the number -2. So just be careful here when you're plugging in negatives. If you have x squared, we want to make sure that we take -2 times -2. So when you do a substitution, make sure you use parentheses, then -5 times -2, and then plus 3. Now -2 times -2 is +4. -5 times -2 is +10. And then we're going to add 3. Well, this is 14 plus 3 more, or 17. Now for the last one, we're going to do the same thing, except for in this case, what we're going to do is substitute in the number 0 for our function. So g of 0 is going to be 0 squared minus 5 times 0, and then plus 3. Well, 0 times 0 is going to be 0. 5 times 0 is 0, and then we're going to add 3. Well, this is nothing. Nothing plus 3 is 3. And that's our review for Chapter 4.